Okay, I'm just going to demonstrate real quickly the Z tracking that we have on our TIG systems. So essentially we've got a start and end position. I'm just going to go ahead and move the Cobot to the start position. You can see that it's close to the material. And then I'm just going to click on the weld end and hit move to weld point. And you can see it's programmed as a flat line. In the real world, parts aren't the same every time. So as you get variations in parts, whether it's a brake press that's bending things a little bit differently, or anything else upstream that can cause different abnormalities in the part, what we can do is simply check one box. So if we just go to our movement parameters and we hit Z tracking, add Z tracking on our weld start, it gives me tracking is now enabled. It tells me, it gives me a box there for my sample rate, and then we'll just play this program. It would weld it perfectly, but to simulate a part that's not the same, we'll just pop a little spacer in there, and then we'll play this program. Okay, and then you can take a look at the weld. You can see that the height remained constant all the way through the weld, and the weld is a nice, beautiful weld, even though the part is not the same as it was when we started the programming.
As Jimmy stated, the torch corrected in Z for the part variation, and on the faceplate of the power source, you could actually see where the voltage range was within plus or minus a tenth. This next example that we're going to run, we're going to leave the end position taut as a flat surface, but at the start position, we are going to set this position high, so where it's not at a nominal flat plate height, so it's actually going to give you a higher voltage reading than what you nominally want. To correct for this, we're going to go to shared parameters, enable Z tracking, and versus using the average read, we will uncheck that box and then enter a desired voltage. On the last weld that we ran, we could see that we were running a nominal 12 volts. So we will play the program from here, and what this will do will correct for that Z height being too high at the start, bring it in, and then track up. In that example, you're able to see the voltage was higher at the start due to our tungsten height being longer, and it corrected down to that nominal voltage and maintained it throughout the end position being taut low to give you the correct weld. Where this is helpful is where you have start height variation and end height variation as well.